Good afternoon. Hope you had a good lunch break. Thank you for coming to this talk on digital inking. My name is Sriram Subramanian, and I'm a lead program manager on the Windows Input Platform team. In today's talk, I'm going to discuss how a digital pen is a powerful tool for creativity and productivity, and how you can incorporate ink in your Windows 10 apps to differentiate the app experience and delight your users. Then I will talk about the new ink platform in Windows 10 and how easy it is to use to enable you to incorporate inking in your apps. Before we get started, I've been asked to remind you to fill an evaluation form at the end for this talk at the end of this. The QR code will once again be displayed at the end. We humans have been using our hands to express ourselves visually and communicate for a very long time. From the early cave painters of the Neolithic age to the development of the Egyptian hieroglyphs and the Indus scripts around 3000 BC, humans have used pen-like implements to communicate and write. By contrast, we have been using the keyboard and the mouse for a very short time in our evolutionary history. The typewriter and the keyboard were only invented in the 19th century. And mouse and keyboard on a computer is much more recent. The mouse only shipped in 1983 with the Microsoft mouse. So given our long history with writing by hand, it's much more natural for us to use a pen. I myself use a lot of different devices at home and at work. Even so, I bring a pen and a notebook with me to my meetings at work. And this is much more convenient and immediate for me rather than pulling out my laptop, logging in, and then typing away noisily with my keyboard. I find myself listening better with a pen in hand rather than looking at the screen. And according to several studies, I retain information better too. I'm sure this is the case with many of you as well. We use the pen as a powerful tool to express ourselves faster, more freely, and in a more personal way. So many activities on this picture are best expressed with pen and paper, whether it is doodling, brainstorming ideas, copy editing. Pen and ink lets us express ourselves visually when words are not effective. It's time to bring these experiences into the digital devices and the apps we are building. I believe that digital inking is the next frontier for human creativity and productivity. Imagine what we could do if we could make inking on devices as easy as pen and paper, but also harness the power of the computer to do things we couldn't do on pen and paper. This opens up several new possibilities. As input comes in from a digital pen, we can leave it as ink. As far as the PC and the device is concerned, ink is a trail of the tool's motion, and the data it represents can be all kinds of things, from writing to sketches to just plain strokes. And if we do this well, it matches the experience on pen and paper. A side note here, since I get this question asked a lot, what's the difference between a pen and a stylus? A pen like this that ships on Surface 3 is a precision device. It actively communicates with the device. It is great at capturing details. It has got buttons for additional functionality, like the eraser button at the end of it here, and then a button in the back for apps to get launched on the start screen, for example. A stylus like this at the tip of a pen is just a soft stylus, and it's just a finger replacement. It is just a stick and not a precision tool. And so once we capture the ink strokes and get the pen on paper experience with just ink drawing, we have the ability to do certain things more easily since we are in the digital domain. The ability to change the color of the ink after the fact, or be able to highlight over the ink. And also, because it's a digital medium, we can mix ink with other content in our documents, ink with text and images and so on and so forth. We can go further with ink by analyzing the ink data and using the metadata to do things like search. I cannot do this with my physical notebook. Of course, I can go a bit further and convert the digital ink into text or shapes. This is useful and a delightful experience for a number of situations, either in a writing app or in a sketching app. To explore this further, let's look at a couple of scenario concepts to see how inking can be used to enhance existing apps. These are scenario concepts and not actual products, but these ideas can help us explore how inking can add a different dimension to an existing app. Take the Maps app. This is something we all have on our devices and that we carry around in our pockets or in our bags. The map control itself is also available for use in many of the apps that you are building. Imagine a vacation or a business trip. The typical thing that I do is go down to the concierge desk and ask for directions to a restaurant or to a place to go to. And so imagine if instead of the concierge pulling out a paper map and marking up with pen or pen or pencil, if they could mark it up on a digital device. And it's much more convenient for me to then carry my device around. But since this is a digital device, it opens up several new possibilities. With the digital map, I can now zoom in much more easily and see more details when I get closer to my destination. Of course, because it's a digital app, I can rotate it or share the map itself with the annotation via email or messaging with the other people that I may be meeting. And of course, the app can go one step further by enriching the experience by integrating it with the compass or the GPS sensor and provide me with turn-by-turn directions. So the digital ink adds a totally new dimension to this scenario and the app experience. Email is another scenario where I can use my pen to write much more naturally with ink and add some personality to my messages. Of course, if I want to send it the traditional way, because it's digital, I can go ahead and convert it to text and send the message just like I would. In this case, inking became a medium, the pen became a more convenient way for me to input the message. Of course, with ink, I can go to the next step and underline the words of interest with my pen, or imagine circling words, drawing an arrow, or doing any number of things we tend to do naturally to draw attention to a particular portion in the message to the audience. Of course, these scenarios have existed for some time. Microsoft pioneered the tablet PC platform more than a decade ago, and it supported these types of apps. And some of these apps are still shipping with these experiences. One of the problems was the availability of hardware devices. The hardware devices that supported pen were expensive and heavy. The good news is that hardware is catching up. Over the last few years, many innovative Windows hardware devices like the Surface Pro 3 have become available that do a great job of supporting pen and inking. The chart on this slide shows the incredible growth of these devices in the market. Over the last 3 years, we have seen a 50% year-over-year growth of devices that support touch and pen. And so today, there are more than 50 million devices ready to run your apps and give users the best experience with pen and inking. So what makes a good inking experience? When we started working on Windows 10, we asked ourselves the question, how can we make digital inking rival the intimacy and simplicity of writing with pen on paper? I believe there are two requirements for a delightful digital inking experience. First, the ink that is rendered on the screen needs to look beautiful. It needs to capture the nuances of your handwriting or drawing, taking into account things like pressure. It also needs to feel like ink flows from the tip of the pen. With a ballpoint pen, there is never a lag between the pen and the ink. Second, using the pen should be comfortable and inspire confidence. Each of us hold the pen in a different way, and we should be able to draw with a natural posture. Both of these things represent a challenge today which we needed to solve to delight our users. I will go into each of these aspects in a little more detail. When we write on paper, the ink is deposited continuously and we see every detail as intended. Our eyes are very good at perceiving those details. The amount of details or the resolution that we can perceive with our eyes varies with the distance. For a healthy adult, at an average reading distance of 1 foot, which is where we typically read when we are reading stuff on screen, the maximum resolution we can perceive is 720 dpi or ppi, pixels per inch. The publishing industry has known this for some time because this is the resolution at which high-end magazines are printed to deliver superior readability. The high-resolution displays on today's devices is around 300 dpi, but some of the premium devices are starting to rival paper in terms of resolution. How do we make sure ink does the same thing? When I put the pen down on a digital device, there is a touch and pen sensor grid on the display called the ITO layer that detects the position and the movement of the pen and reports it to the OS at a certain resolution and rate. So rather than continuous ink strokes in the analog medium, the OS sees a series of discrete points that it needs to process and render into ink strokes. Also, when we write or draw, our hands vary pressure depending on what we are doing. We tend to do it intuitively without even realizing we are doing it. For example, when I write English text, I notice that I tend to reduce the pressure at the end of a stroke. In order to render beautiful ink, we have to effectively fit the points that we get from the sensor into a smooth curve and incorporate things like pressure to draw a realistic looking ink. The good news is that we are taking care of this in the new platform with Windows 10. Let me show you a demo to give you an idea of what we have done with beautiful ink. Switching to a demo machine here. First, I want to show you an existing app using Windows 8 APIs that has implemented inking to give you an idea of what's the problem we're trying to solve. Let me zoom in slightly. So when I mark it with my pen here, notice what happens. The strokes subtly changed when I lifted the pen. Let me show it to you one more time. Do you see that? So what's happening here is that as the ink data comes in as discrete points, the stroke is constructed by connecting them as the strokes come in. And then when I lift the pen, the entire curve is processed, smoothened, and re-rendered. So that creates a subtle shift that our eyes can see very easily. Some applications have worked around this by doing their own rendering with a lot more processing and writing lots of code. But there is typically some trade-off in terms of memory or performance. Office OneNote is one of the apps that have done this. So here I have a test app that I've incorporated the Office rendering, and then I'll also show you how the new platform is doing it. So with the Office style inking, when I draw the strokes, there was no change in the stroke. It's smooth when I lifted the pen. And you'll also notice that it took into account pressure, so the ink stroke is thinner at the end of it. But even though this looks smooth at the normal resolution, when I zoom in, you can see there is still a series of discrete polyline segments that are connected. So it's not perfectly smooth, and at certain types of curves, our eyes can still see it. So we decided to address this as well as address the memory and performance considerations in the new platform. So when we switch to the new renderer and show the same thing. So here when I drew similar curve. Now when I zoom in, you will notice that it is perfectly smooth even when I zoom in quite a bit. I can keep going here. Also notice that at the end of the stroke, the pressure from this pen, by the way, can support 256 levels of pressure, is captured, and so the ink looks much more natural and pleasing to the eye. Once we have achieved this default level of smoothness and beauty with the ink, we can go furthermore to beautify the ink. I can, of course, vary the thickness of the pen. And this is useful for languages where cursive writing is much more prevalent, like Hindi, for example. DirectInk supports not just changing the width, but also other aspects of it, like the aspect ratio and the rotation. And so let me draw a few more things here. And so when I change the aspect ratio and the rotation, you can notice that we can bring cursive writing to life. And this rendering is happening on the fly, and it's, as you can see, it is really fast because all ink rendering in Windows 10 is done using the GPU on DirectX 12. The other aspect of this challenge is to make sure digital ink follows the user's pen as well as pen on paper. Any lag between the pen and the ink is perceived by the user as latency. Today, with a typical Windows 8 app, like the Reader app that I showed you, there is a perceivable latency of anywhere between 80 to 100 milliseconds on current devices. There are three things that cause this latency. First is the pen hardware latency. This is the time between when the pen hardware itself, the time that it takes the pen hardware to report the data to the OS. The second thing that causes latency is the processing of that input and rendering by the OS and the app. And finally, there is some latency on the output side. This is the time when the ink is rendered and it's presented to be displayed, and then there is a small amount of latency in the display system itself to light up the pixels that the user sees. With the work we are doing in Windows 10, we are working hard to address this latency end to end. Through user research, we have determined that at an average writing speed, most users feel that inking feels on par with pen on paper if the system is able to deliver an end-to-end latency of 50 milliseconds. We are confident of achieving this with the current hardware on Windows 10. And we are working very closely with our hardware partners to reduce the latency further in the next generation devices. Here is a quick video to illustrate this. This has been captured with a high-speed camera. The top pane is showing ink rendering on a current Windows 8 application, and the bottom pane is rendering the same thing with the Windows 10 app, test app. And as it draws here, you'll notice that the gap between the pen and the ink trail on the top pane is quite a bit in Windows 8, and we have reduced it by almost 50% in Windows 10. And with the next generation hardware, we are hoping to reduce it even more. I mentioned that earlier, for a great inking experience, using a pen should be comfortable and inspire confidence. We all hold the pen differently. Majority of us are right-handed, statistically, but a good percentage of us are also left-handed. And even within these two major groups, there are variations in how we hold the pen, as you can see in these pictures. I myself hold the pen such that my pinky is trailing my hand. But I feel like no matter how you hold the pen, we should ensure that writing feels natural. For the user to feel confident, the system should not leave stray marks from the pinky in my case, or the knuckles, or the side of the hand. The system should not lead to accidental zooming of the content because the surface supports both touch and pen inking, touch manipulation and pen inking. These are things that users experience today, and we are improving the experience with the new inking platform. So let's talk about the new platform. With Windows 10, we are introducing a new inking platform built from the ground up called DirectInk. It is designed to handle pen input and ink rendering efficiently for your apps. We are doing work in the Windows input infrastructure to bring input support, ink support, to Windows Phone and other mobile devices running Windows for the first time. This means that users can ink even on devices that only support touch, like most of the phones that we carry around. The platform takes care of rendering beautiful ink with low end-to-end latency, like you saw in the demo. DirectInk models the pen pressure to create realistic ink with smooth curves, and we render those curves using a fast Bezier algorithm on the GPU using DirectX. The platform optimizes the ink input processing and rendering infrastructure to reduce the end-to-end latency. As you saw in the video, we are making great progress here. I encourage you to come up later and try it out on my device, because it's hard to capture that on video, but it's easier to see it by yourself. Next, we are improving the user experience with inking. With DirectInk apps, users are able to comfortably rest their palms while inking and have the confidence that the pen will ink and their palm or finger won't cause unexpected things to happen. Finally, we want to make it easy for you to add ink scenarios in your apps. Our goal was that it should be possible to implement a default level of functionality with just a few lines of code. At the same time, we want to provide a rich set of APIs to provide flexibility and power in your applications. Here is a high-level view of the ink platform with each level representing additional levels of functionality, flexibility, and power. The ink canvas is a XAML control, and this is your entry point for inking in Windows 10. Makes it really easy for you to add inking functionality to your apps. We'll see this in a moment. The ink presenter gives you the next level of functionality to do more with ink and enable you to configure different aspects of ink input handling and rendering. Windows has always been about giving developers more power and flexibility if they need it. So if you have that need and want to have fine control over ink input processing or implement advanced scenarios like ink recognition, the API is scalable and powerful for that. Let's take a look at ink canvas in code. Here I have a simple XAML application, and it's already set up with some simple, you can see in the designer, it's set up with a grid and some text blocks and whatnot and ready to receive ink. And I'm going to go ahead and add an ink canvas here and run the app. And so here you go. So I can, just with that single line of code, I have enabled inking in this app, and I'm able to ink on it. So, and also because ink canvas collects the ink and supports erasing by default, if I make a mistake, I can go ahead and erase the strokes, do it again. And the ink looks like it did in the demo, looks beautiful. It takes pressure into account. You can see the ink is thinner at the end of the stroke, and it's you're able to see the ink following the pen cursor. So I've been able to do all this with just a single line of code. In contrast, doing the same thing in Windows 8 would have involved dozens of lines of code and involving your app doing its own rendering, and still it may not be able to get to this level without a lot of work. Let's get back to the slides. Ink Canvas is great for enabling ink in your apps and getting the platform to do the heavy lifting like you saw just now. But in many of your apps, you may want to do more configuration and customization to enable richer scenarios. For example, by default, the ink canvas is configured for inking with pen only. Touch input is assumed to be passed on to the app for touch manipulation. But let's say if you want to target your app for both desktop and mobile users and want to configure it for both pen and touch to do inking. Ink Presenter has a way to do that. Or you may want to allow your users to change the ink color or thickness. Each ink canvas instance has an ink presenter associated with this. Ink Presenter allows you to change the default configuration. It also allows you to get at the ink stroke data and persist them for later use. There are a lot more advanced customization options possible that give you the flexibility and power. We won't have time to cover this in this talk, but there is a follow-on talk at 5 p.m. that goes into a lot more details on harnessing the full power of digital inking with DirectInk. Let's go back to the XAML signature app that we just saw. So first, I'm going to configure this app to support both pen and touch inking. So to do that, I get the ink presenter object from the canvas, ink canvas, and then I set the input device type to support both pen as well as touch. So let's go and add that code. Next, I want to wire up the clear button that we have in the designer to be able to clear the signature in case I got the signature wrong when I run the app. And so because ink canvas, as I mentioned, collects the ink as the user is inking away, I can get access to them using the stroke container, and then all I have to do is clear the stroke container. Once the stroke container is cleared or updated, the ink presenter takes care of re-rendering the content. So let's go and add that code. Next, I want to be able to save the ink once I am happy with my signature. And so here I have a bunch of boilerplate code in order to specify the name of the file, where I want to store it. In this case, I am storing it in the pictures folder. But the key API to call is the save async method that is part of the stroke container. So in this case, the stroke container has the signature that is collected in this app, and save async will go and do the work of saving it into the standard ISF file format. So let's go and add all that code and run the app. So now I can ink as before, and of course erase it. But because now I'm enabled both touch and pen inking, I can use the stylus I showed you before, and I can use it to ink with that as well, or my finger. And we wired up the clear to clear the ink stroke container, so I can clear the signature completely, and I can add the signature, submit it, and it gets saved in the pictures folder. And you can see that the ink is saved in the ISF format. The ISF format is a GIF container, and it stores both the native ink data as well as a GIF representation of that. This program is showing the GIF representation of that data. And because this is a universal Windows app, I can deploy the same app to my phone. So I happen to have deployed that app on this phone beforehand. And so let me quickly show you that. Oh, there it is. And You can see the same app working on the phone. Next, I would like to make you aware of a standard UI control called the ink toolbar. This is the same UX control that is implemented within the Microsoft Edge browser for note-taking with ink. The ink toolbar is a collection of several common tools like highlighter, ink color picker, and the ink thickness adjustment packaged into a simple-to-use XAML control. It's the easiest way to provide a consistent inking tool UI in your app. The ink toolbar control is still in beta, but you can check it out through the Visual Studio gallery. It is downloadable as a free extension. With the simple XAML app that we built, the signature app, I showed you how easy it is to use DirectInk and implement inking in a typical enterprise type scenario. But inking is not just about static content. We can imagine doing the same thing with other types of content, video, for example. So we built a simple video annotation test app to try it out. So let me show you that. So here is a simple XAML app that opens the video and plays it. And this app comes with typical VCR controls. But what I can do is I can pause it and mark it up. Keep playing the video some more. And these annotations stay with the video. So if I were to stop the video and share it with someone else and they play it, the annotations are exactly where I put them. And you can imagine that this is useful for a number of scenarios. I can imagine a sports coach looking at the videos of the last week's play and using the video to show his team how they could have done better. These are interesting apps. But today I am really thrilled to be able to show a couple of partner apps. Through the Windows Insider program, a number of you have already started evaluating the Windows 10 APIs and through the developer preview builds. The first app I want to show you is a universal Windows app called JT2Go from Siemens that enables users to manipulate 3D content using touch. This morning, Guggenheimer showed it off on the Surface Hub running that app. But here I have it running on Surface. And so this app allows you to open 3D models and enables you to manipulate it using touch. But the cool thing is now I can use the pen tool and start annotating this content. And so in this case, ink makes it really easy to imagine a situation where engineering diagrams in the future are reviewed using this mechanism. The next one I want to talk about is an app called QQ from a company called Tencent. As some of you may know, let me switch to the machine. QQ is a very popular messaging app from China. It has more than 800 million users worldwide, and it's deployed on all platforms. So QQ allows users to do several things. They can write a text message. So in this case, I'm sending a message to my friend Zhengfeng. It allows the user to send images. So I can send a picture over. So what QQ did was looked into adding inking to this application, and they, with just a few lines of code using DirectInk and the ink canvas, they were able to enable inking. So now I'm able to use the ink whiteboard and then write a much more personalized message to my friend Zhengfeng. Furthermore, I can go back and use the ink whiteboard and annotate that picture that I showed earlier. And send that over as well. So this is an example where with just a few lines of code, QQ was able to provide a much more richer and personal experience to their users. Next up is a universal Windows app from a startup in Florida called Silicon Benders. The app is called Sketchability, and I would like to invite Ryan Harris, a co-founder, one of the co-founders, to show you the app and their experience leveraging DirectInk. Please welcome Ryan Harris.
Thank you. My name is Ryan Harris, and along with my brother Miles Harris, we developed an app called Sketchable. It's a sketching and drawing application on the Windows Store, and it allows you to create digital journals and store your images as pages in them. When we set out to develop Sketchable, we wanted to make the fastest and most powerful mobile sketching application on any platform. And we also wanted to find a useful place in a creative's workflow. To do that, we had to beat traditional mediums and other mobile applications. So when we started looking at the creative process, we noticed one thing, that despite the user's skill level, whether they were a professional artist or really struggled to express themselves visually, they always used a tool, a pen, a pencil, a brush, something to help them express themselves. So to limit an application to purely touch input would fail this universal standard that we all have. And this made Windows an extremely appealing developing platform for us because they have the active pen. One of the key things that it allows us to do is get at pressure. So I can very quickly and easily make a stroke that varies in diameter based on the pressure provided. You can also apply this to other settings like opacity. So now I can quickly change the opacity and the diameter of my stroke based on pressure. And the pen provides much more than that because it allows me to be more productive because it provides a more natural experience as opposed to you painting with a finger, selecting, painting with a finger, selecting. I can differentiate between my inputs with touch and stylus, and it frees me up to do more things. I can, say, assign a tool to touch that requires less precision, like smudging and smearing. Since the stylus has a secondary button, I can have a secondary tool attached to it. So without involving any UI, I can switch between 3 different tools just depending on how I interact with the canvas. It also allows me to free up touch for gestures, like 2-finger panning and zooming, we all know and love, and 3-fingered swipes through the undos and redos. This is the kind of natural expression that we provide in our editing mode. And we wanted to bring that into other aspects of our application, and we've done that through DirectInk. So if I go out back to our page, a prominent feature we gave was the ability to name one of your journal pages. And even our power users didn't know it was there because it's not as intuitive as the rest. It's kind of your classic text input. You push a button, press the text field, launch a keyboard, type in your title, and then it would be there. So discoverability is low, and the number of steps is very high. With the power of DirectInk, we can increase discoverability by putting a text field in when you come within range. And it provides, even as bad as my handwriting is, very excellent handwriting recognition. So in much fewer steps, in a much natural and much easier to understand flow, I can get the same result. And the best part of this is that we implemented DirectInk in less than a day, which is longer than the time it took us to do the traditional text input through keyboard. And it's really made us very excited about the potential for this and other features of our application.
Thank you, Rai.
Thank you.
I really want to thank all the 3 third-party partners who allowed us to show their apps. They are all in the audience. In addition to Ryan, we have Mr. Zhao from QQ. He's the team lead for QQ somewhere in the audience. And Joe from Siemens is sitting back there as well. So thank you very much for allowing us to share your app with the rest of the audience. So the Ink Canvas and the Ink Presenter gives you an easy way to implement great inking functionality in your app. You saw several examples of that. But the platform has more. As I mentioned, the platform is flexible and powerful enough for you to implement even richer scenarios. These include ink recognition, ink editing, and more. There's a follow-on talk at 5 p.m. to cover some of these in much more detail. Please attend to learn more about these capabilities. Also, we have a few samples, and we are going to post more samples on GitHub to learn more about the DirectInk APIs. Here is a recap of what we covered today. Pen is a great tool for enabling productive scenarios in your app. There are now millions of pen and touch-enabled devices in your customers' hands. So your app is ready to shine on these devices. With Windows 10, the new Ink platform is built from the ground up to start rivaling the pen on paper experience. The smooth ink demo you saw and the inking in the apps that I showed that you saw hopefully gave you a good idea of the capabilities. Finally, the DirectInk API makes it really easy to start building inking functionality in your apps. I would like to leave you with a simple call to action. Differentiate your universal Windows app with inking today. We have built a powerful platform for you to be able to do that. Your customers have the devices to run your ink-enabled app. Please check out the APIs and send us feedback at DirectInk at the following email address, directink@microsoft.com. Please submit your feedback for the session. We have time for some questions. And if we run out of time, I'm going to be outside to talk with you as long as you want. Thank you very much for coming. It's been a pleasure to talk about this. For this release, this is all for universal apps.
I have a question regarding text recognition. So when you perform OCR, I would say, does it require any kind of connected states, or should the device be online, or it can be performed in offline mode as well?
Okay, good question. So ink recognition is built into the platform, so it doesn't need to be connected. It's part of the operating system. And so text recognition works with some 30+ languages on the desktop, and you don't have to be connected, or online in order to have the recognition work. At the 5 p.m. talk, there is a little more detail on how to use the recognition APIs.
Thank you.
So I have one question. Do you have any plan supporting the Win32 API?
I'm sorry, I didn't get the question.
So Win32 native app, any plan for that?
So right now, this functionality is available for Universal Windows app. Win32 is something we are looking into.
Just a follow-up question to the handwriting recognition. Do you know if any improvements have been made for like Japanese or Chinese characters? I know like Windows 8 was very good with like English, Roman characters, but it wasn't so good on foreign languages.
I don't have anything specific to talk about in terms of improvements there, but we can talk offline about what specific things you are noticing, and I would love to get that feedback. All right, thank you very much. I am going to be around if you have things to talk about or more questions. And then please, I hope to see many of you at the 5 p.m. talk to learn more about the advanced capabilities of digital ink with DirectInk. Thank you.